If you will not pass this kind of question in WAEC chemistry exam, it means you do not pay attention to this lesson. WAEC used to give this kind of question every year because mostly students fail practical question like this. And today I'm here to explain this question step by step. I'm going to solve this question in a way that you students you should understand, and for you to be free with WAEC practical chemistry question like this. So without waste of time, let's read the question. So the question says that a solution of hydrochloric acid HCl is titrated against a solution of sodium hydroxide NaOH. 25 cm³ of sodium solution was prepared into a conical flask and a few drops of phenolphthalein indicator were added. The solution was then titrated with 0.100 mol dm³ of hydrogen chloride. The average volume of acid used was 20 cm³. Write a balanced equation for the reaction. B. Now I'm reading the equation now. B. Calculate the numbers of moles of HCl used. C. Determine the number of moles sodium hydroxide in 25 cm³ of solution. Then D. Calculate the concentration of sodium hydroxide mole dm³. Then if sodium hydroxide was prepared by dissolving 4.0 gram of sodium hydroxide in 1 dm³ of solution, calculate E now the molar mass of sodium hydroxide. F. The percentage purity in the sodium hydroxide used was pure. So this is the question that we are asked to calculate. So the first thing here we have to do by starting to solve this question is bringing the data given. So bringing out the data from question out for us to know what is the next thing to do. So data given. So our data in the question here, we have volume of HCl is equal to 20.0 cm³. Volume of sodium hydroxide is 25.0 cm³. And the next thing here is concentration, that's count of HCl is equal to 0.100 mol dm³. So the next thing to do is our first question. After bringing out our data out here, then we now go ahead to solve our question. So the first question here is A. Now in this question they say write a balanced equation for the reaction. So we have two compounds here reacting. The two compounds here reacting are hydrogen chloride plus sodium hydroxide. So if these two react together, they will give sodium chloride plus water. So let's see whether this equation is balanced. Now let's count how many hydrogen are in the reactant side. We have 1, 2. In the product side we have 2. It means hydrogen is balanced. Let's see chlorine. Chlorine here is 1. Chlorine here is 1. That is correct. The chlorine is balanced. So the next is sodium. Let's see our sodium in the reactant side. Our sodium in the reactant side is 1 and the product side is 1. It means our A, the equation of reaction, is balanced. So the next question is question B. And question B says that calculate the number of moles of HCl used. So before we talk of formula, let's convert our volume to dm³ first. So our step 1 in solving question B, step 1 is to convert volume to dm³ cube. Our volume, which is in cm cube, we are to convert it to dm cube. So we have 20 divided by 1000. 20 cm cube is the average volume titer of hydrogen chloride gotten from the titration. So if you are converting cm cube to dm cube, it means you are dividing the value of cm cube all over 1000. So if you press your calculator, when you divide this, you will now have 0.0200 dm cube. So the next thing to do is step 2. The next step is step 2. So in step 2, we are to use formula. We are to use formula. Now, the formula we are to use in this question is N is equal to C times V. C is the concentration of HCl, and then the V is the volume of HCl in mole per dm cube. So step 3, we have to substitute. So now step 3, we have our C is equal to 0.100 mole per dm cube times 0.020 dm cube. So first of all, you see that dm cube will cancel dm cube. So if you multiply this value by this value, you will now have 0.002 mole. So this is a mole of HCl. The next question here is question C. Question C says that determine the number of moles sodium hydroxide in 25 cm cube of solution. So as we know, the rule implies that since 1 mole of hydrogen chloride is equal to 1 mole of sodium hydroxide. 1 mole of hydrogen chloride is equal to 1 mole of sodium hydroxide. It means 0.002 mole of HCl is equal to 0.02002 mole of sodium hydroxide. Therefore, mole of hydroxide, sodium hydroxide is equal to 0.002 mole. So this is our final answer for C. Question D. Calculate the concentration of sodium hydroxide mole per dm cube. So we are going to rush step 1. Step 1. Convert volume to dm cube. So in step 1, we have to convert volume to dm cube. So what is the volume of sodium hydroxide in this question? The volume is 25 cm cube. For us to convert 25 cm cube to dm cube, we divide 25 by 1000. So 1000 cm cube. You see that cm cube will cancel cm cube. When you divide this, it's equal to 0.0250 dm cube. So step 2. In step 2, we are to use formula. Now, this is the formula we're using. C is equal to N all over V. And we already have the value of N we calculated in the question, which is 0.0020 mole all over 0.0250 dm cube. So our answer is equal to, when you divide this value, you are going to get 0.080 mole per dm cube, because you have mole and dm cube here. You are just dividing the values. So you see that our answer of question D now is successfully given. So I said something earlier. There is another way we can calculate this and arrive at this. No, most of you you'll be asking, why is it that I didn't use CAVA in this question? But I will tell you, let me give you the proof first. If you are using CAVA, if you are using CAVA all over CB VB equal to NA all over NB NB, you arrive at the answer exactly. So let's go ahead. Now we are looking for CB. The question is asking for CB, that's sodium hydroxide. So let's make CB subject formula. We have CB is equal to CAVA cross multiply NB is equal to VBNA. So now our Na in the question, our Na, that's concentration of acid, is 0.100 times our V is 20.00 times 1, because our NB is equal to 1. So divide by VB is equal to 25.0 times 1. Now if you divide these values here, you multiply and divide, you are going to get CB is equal to 0.080 mole per dm cube. So you should not be confused, because using that formula, the reason why we do not use this formula is because already we are asked to calculate the number of moles of hydrogen chloride, and we are asked to calculate or determine the number of moles of sodium hydroxide. That's why we use that step, and because of that the step will be more easier for us. So but from you, which anyone you use is okay, yes. But what I want you to be careful of here is, you can see that the other step we follow, the formula, I used it and solved before. I convert the volume into dm cube, but this one we are not converting the volume into dm cube. So that is the difference between using that one from this one. This one, no need for you to convert the volume to dm cube. So our next question, which I cancel because of not enough space, the question is E. The question is E. The question said that we should calculate the molar mass. Calculate molar mass. So in calculating molar mass, we have to add the atomic masses. We have to add the atomic masses of sodium hydroxide. So we have to add the atomic masses. So we have Na is 23 plus oxygen is 16, hydrogen is 1. So 23 plus 16 plus this, it will give us 40 gram per mole. So molar mass is measured in gram per mole. The last question we have in this question is F. F says that calculate the percentage purity. So we are to calculate the percentage purity of sodium hydroxide that was dissolved, whether is pure. Now, first step we are to look on here is the mass of sodium hydroxide. The first step, step 1. In step 1, find the pure mass of sodium hydroxide. Now, we have to find the mass of pure hydroxide. So, the formula we are using to find this pure mass, we have a formula where mass is equal to number of moles times molar mass. Use the formula and find pure mass, and after when you find your pure mass, then use percentage purity formula, which says percentage purity is equal to pure mass divided by impure mass times 100. After when you get your final answer, drop it in a comment section so that I will see. Thank you for watching. If you see this video helpful to you, like, share and subscribe. Also, don't forget to hit the notification bell for more chemistry, WAEC, practical questions like this. See you in the next lesson. Since our impure mass is given in 1 dm cube, which is 4.0 gram in 1 dm cube, so we are not going to use this formula. We are going to use the formula mass is equal to mole per dm cube times molar mass. So the mole per dm cube that we calculated in the question is 0.080 mole per dm cube times our molar mass, and the molar mass is 40 gram per mole. So when we multiply it, it will give us 3.2 gram dm cube. After getting our mass in gram per dm cube, then we now use formula, and the formula of percentage purity is mass of pure substance divided by the mass of impure substance times 100, and the pure substance is the calculated mass we just calculated, which is 3.2 gram per dm cube divided by the impure mass, and the impure mass is 4.0 gram per dm cube multiplied by 100. When you multiply the value and divide it, it will give you 20%, and that's our percentage purity of the question.